Okay, let's give you guys some more practice. So now we're back on Earth. Um, Gravity on Earth is 9.8. We're going to fire the cannonball at 70 meters per second at an angle of 69 degrees. Calculate the maximum height and the range. So when you fire this, the maximum height is this distance here. So work out this maximum height and also work out the range. Okay, so this distance here is the range. Okay, so think about it, press pause, and have a go. Okay, so first thing you should do, break this up into two components. So it will look something like this. Hang on, hang on, let me just move it. Hang on. Be here. So first thing you should do is break it up into the vertical and horizontal components here. So the vertical will be this, horizontal will be this. Okay. Hang on. Uh, and and then jump to your velocity time graph. So this is your velocity time graph. This is the equation for this line here. Um, the time it takes to get to the maximum height, let's call it T max. Well, that's this point here. So now you've got to put the zero into that V to find out the time it takes to get to the maximum height. Because at the maximum height, the velocity is zero. So you put zero into the V to find out this T. That would represent the time it takes to get to the maximum height. So put zero here into the V, and then take the whole thing down here, and then try and work out T here. Okay, so blah 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 here, blah blah blah. So T equals this. So this represents T max. T max here. So the time it takes to get from here to here is given by this. This is T max. Okay, and then once you've got T max, then you can work out the total height of the cannonball, the maximum height of the cannonball. So the maximum height is given by this area here. Well, you know the time it takes to get to the maximum height, and you know this here, this length here. Well, this length here represents the initial vertical velocity, which happens to be this. So it's basically to find out the maximum height, it's this times this length here, and then cut it in half. Okay, so maximum height here, maximum height equals this thing here. Hang on. So now equals this thing here, which is given by this here. Okay, and then you times the across here. Well, the across here is given by T max. That's T max is the time it takes to get to the maximum height. So so hang on. Let me just move this a bit. Hang on, bear with me. So it's basically getting the height. Hang on. So it's basically getting this times this, and then divided by 2. So it's basically this times this, and then divided by 2. Okay. This here is really ugly because you've got a fraction within a bigger fraction. So let's try and tidy up. So let's just look at the top part only. The top part only is this. Okay. So you've got this thing here multiplied to the top. So it's 70 times with the 70 here. That gives you this, and then sine 60 is the same as sine 60 here. So it becomes sine squared. 69. Sine squared 69. Okay, and that. So basically, we are just getting this multiplier to the top. And don't forget, you still got the over 9.8 here. So that top part is this bit here. Okay, divided by 2. Now, this here looks really ugly because you've got a fraction within a fraction. So visualize it, divide by 2 as this. Just rewrite this thing here as this, and then visualize the divide by 2 as divide by 2 like this. So when you divide a fraction, it gets multiplied to the bottom. So this here becomes this. Okay, so get 2 times 9.8. That gives you this. So the maximum height is given by this here. Okay, so now we've got the maximum height, which is given by this, and you can leave it as this. Um, and then now we know the time it takes to get to the maximum height, which is given by this. Remember, this here is the time it takes to get from here to here. Okay, so then you need to find out the total flight time. Well, the total flight time is 2 times the maximum height. So you see, when you fire this up, and then the time it takes to get down is the same as is exactly the same time as it takes to get to its maximum height. So what I'm trying to say is that this distance here is the same as this distance here. So you basically just get this times 2. Okay, so basically this here is the time it takes to get to the maximum height. You times by 2. When you times a fraction, it gets multiplied to the top. So this 2 here will merge it with this 70 here. Okay, so it becomes 140, and this thing here stays the same. And then you've got your 9.8 here. Okay, and then well, now that you've got your total flight time, okay, this is your total flight time. Then imagine you and your dad sitting in a car here, driving at the horizontal velocity of this. Remember, we broke up the diagonal thing here. So the horizontal velocity is given by this 70 cos 69. Okay, so once you've got your flight time here, to get the range, you get the horizontal velocity times by the flight time. Okay, so this is the horizontal velocity times by the flight time here. So this gets so here you've got this multiplying a fraction, so it gets multiplied to the top. So merge the 70 with this 140 here. That will give you this, and then this stays the same, and then you've got this here stays the same, and then the over 9.8. Okay, so anyway, the overall range is given by this. Okay, and we can leave it as this. Okay,